Our next section is on describing quantitative data with numbers. We'll take a look at mean, median, standard deviation, interquartile range, outliers, and how to make a box plot. Our mean is the most common measure of center. Mean is what you typically think of as average. To find the mean, we take the number of observations or number of pieces of data, add the numbers together in our data, and divide by however many there are. We use the value that we end up with and call that our average or mean. We use the symbol of what's called X bar. X bar is used to find the mean, and we also have a Greek symbol which is called sigma, which is a short way to say add everything together. So the way that we use our formula for mean, X bar, mean, equals add all of the values together from the observations and then divide by however many numbers you have for the observation. The other common way to measure a center for data is a median. Our median is the middle value. If we have an odd number of values, we're going to simply take the middle value or the center value. If we have an even number of observations, we average the two center values together. Let's look at an example. This is an example of 20 randomly selected New York workers that commute in minutes and what their commute time is. To find the mean, add all of the values together, divide by 20, and we get 31.25 minutes. If we order all the numbers in a stem and leaf plot from this set of data, we can then find the median. The median, since we have an even number of values, we have to average 20 plus 25 divided by 2. Our median ends up being 22.5 minutes. We'll use mean and median throughout the course for different reasons. The mean and median, if they are a roughly symmetric distribution, however, are going to be close together. They will be exactly the same value if the distribution is exactly symmetric. And if we have a skewed distribution, the mean is usually further out in the tail than the median. Since we need to be more specific, sometimes we're going to look at what are called quartiles. Quartiles and interquartile range help us determine a better way to find different parts of data. We know that the median is our center value, and to find the quartiles, we're going to, similarly as in the median, arrange the observations in increasing order. The first quartile, or Q1 as it's called, is the median of the observations to the left of the original median. The third quartile, or Q3 as we sometimes call it, is the median of the observations to the right of the original median. Back to our example on the New Yorkers. We found the median already to be 22.5. We then can locate from this the middle value. In this case, we have an even number once again from where the median was, which is actually in between these two values here. And we're going to then average 15 plus 15, which is simply divided by 2, 15. Then over here, same thing. From this line, we have an even number of values, so we have to average these two numbers, 40 and 45, together. We get 42.5. To get the IQR, subtract 42.5 from 15, which is 27.5 minutes. We would then say the range of the middle half of travel times for New Yorkers in our sample is 27.5 minutes. To figure out if there's any outliers, we then use the interquartile range to figure out exactly where those are. In order to find it, we use what's called the 1.5 times IQR rule for outliers. If it's in fact an outlier, it will fall more than 1.5 times the IQR above the third quartile or below the first quartile in our data. In our example, we found the IQR to be 27.5 minutes. We multiply 1.5 times our IQR of 27.5 and get a value of 41.25. To find the first outlier, take Q1 minus that value we just found, which is 15 minus 41.25. To find the next outliers, take Q3 plus the 1.5 times IQR. We end up with 83.75. Did we have any data that's shorter than negative 26.25 minutes or longer than 83.75 minutes? In fact, we did. We had an 85. That would be then an outlier. We use what's called the 5-number summary to help us to analyze statistical data in AP Statistics. The 5-number summary consists of the minimum, smallest observation, the first quartile value, the median of all the observations, the third quartile value, and the largest observation, which we refer to as the maximum. A 5-number summary tells us how to then make a box plot. We draw and label a number line that includes the range of all of the distribution of observations. Then we draw a central box from Q1 to Q3. We note the median inside the box. We then extend lines which are called whiskers from the box out to the minimum and maximum. We're back to the New York example. We're going to construct a box plot. We've already found the median, Q1 and Q3. We also know what the minimum and maximum are. Now recall, as it says, that the 85 is an outlier by the 1.5 times IQR rule. Our box plot then, the box starts at Q1, the box will end at Q3 on our line, and then the median will be noted with a line on our box plot. We then draw a line, which is called our whisker, out to the minimum. Draw a line out to the value 65, which is going to be then the largest value. Because 85 is an outlier, it has to have its own point. So notice again the whisker only goes to the value 65 because 85 is an outlier. We denote that with a point outside of the whisker. Our most common measure of spread looks at how far an observation is from the mean. We call this a standard deviation. We consider the data on the number of pets owned by a group of 9 children. We calculate the mean, calculate each deviation from the mean, which the deviation is found by taking the observation value minus the mean. Our mean, x bar, is 5. Our deviation for the first value, take 1 minus 5, would equal negative 4. Another deviation, for example, if we take 8 minus 5, we would get a deviation of 3. We then are going to take each of the values we found for the deviation and square it. We find the average squared deviation and calculate the sum of the squared deviations divided by n minus 1, which is the number of observations minus 1. This is what we call a variance. The square root of the variance is called the standard deviation. So let's look at our example. Here are each of the observations on the dot plot. Take each observation minus the mean. These are all those values. Take each of those answers and square them. Take our average squared standard deviation, we'll get to in a sec, but our average squared deviation, which was 52 divided by 9 minus 1, or 8 observations, which is 6.5. This is called the variance. Now we get the standard deviation, square root of that, 2.55. The standard deviation then measures the average distance of observations from the mean. Again, it's calculated by finding an average of the squared distances and then take the square root. The average squared distance is often called the variance. Here's another formula that we use in AP Statistics. Standard deviation, take the square root of 1 divided by number of observations minus 1 times the sum of the observation minus the mean squared. As you saw on the previous slide, using a chart oftentimes is much easier than trying to write everything out within the formula itself and doing the problem in steps. Now we have a choice between two descriptions for center and spread. We can either use mean and standard deviation or median and interquartile range. Median and interquartile range are usually better than the mean and standard deviation for describing a skewed distribution or a distribution with outliers. Use mean and standard deviation only for reasonably symmetric distributions that don't have outliers. And please note that numerical summaries do not fully describe the shape of a distribution. Always plot your data so that you can see what it is you're supposed to be figuring out according to the observations.